So if you just recently joined, click on that link to look at what we're going to learn about today. I have a couple announcements. So reminder, if you are behind pace, join my classroom anytime between 9 a.m. and 4 p.m. to get help. And a lot of you guys have been jumping on that because spring break is around the corner. And so there have been more people in my classroom this week than normal. But I still normally am free for most of the day. So for anytime between 9 a.m. and 4 p.m., you can join my classroom to get help. The other reminder is to check out my YouTube channel because on my YouTube channel, I have tutorial videos and I'm going to be uploading more before spring break because there's certain things that most people ask questions about. I have almost 300 students and a lot of them like in different classes as well. And a lot of them have like consistent questions whenever it's a specific class of like the same types of questions. And so I make YouTube videos to kind of cover those topics. And so if you're on spring break and you want to have answers to your questions while we're on spring break, you can watch my YouTube or check my YouTube channel for that. So remember to look at my YouTube channel. And then I'm going to ask a couple icebreaker questions here. So are y'all ready for this? First of all, if you could have any animal be domesticated to be your pet, what animal would you pick? So like you could tame and it would be like a safe domesticated animal. What animal would you pick? An otter, a lobster, a fox, a wolf? Mark said like and subscribe. Yes, like and subscribe to my YouTube channel. What other animals? A panda, a cheetah, a raccoon? There's any animal in the world that could be tamed. Like you could magically tame it to be your pet. A crocodile, a whale. Okay. I have some questions about that, Zakarian, but okay, a whale, a shoe-billed crane, that's so specific. A lion, you name him Aslan. I love it. A bear, a shark. Do y'all have like a pool? You guys, I love this. I guess the assumption is you also could have like water for it. Venomous animals. Okay. This is interesting. Okay. A tiny person. Now, that wasn't part of the question, but I love it. A dragon. Okay. A penguin. Okay. I am set on the penguin idea. I think that's pretty cool. I actually haven't thought about this question for myself because I feel like some animals are actually like super smart and unique and niche and intelligent, and it would be really fun to look up like which one I would want. It's too hard to answer. It'd be hard for me. Okay, what topping is best on pizza? Okay, I like your response, Kirian. Yeah, that's true. What topping is best on pizza? Joshua says pizza. Okay, Italian sausage, pineapple, pepperoni. No mushroom? Anybody mushroom? Pepperoni, cheese. Y'all are like classics, you know? Sausage, ham. There's nothing, is there anything that's kind of weird? Okay, mushrooms, bell peppers, black olives, bacon. Yes. Okay, I'm loving the sardines. Okay. Ooh. I don't know if I can do sardines. Okay. I'm just curious. Those are some interesting responses there. Last one. What is something that you guys are looking forward to over spring break? Is there something like that you guys are going to get to do over the spring break? Is there like an event you're going to, or you're seeing friends, or you're going somewhere? Tristan's having a birthday. Y'all remind me, we have to tell Tristan happy late birthday when he gets back. You're going to Alaska. Playing Skyrim. Okay. Museum. Going to Vegas. Oh, wow. Okay. For your uncle's wedding. That's cool. Nothing too special. I'm going to get to go, like my sister-in-law is getting married, and so we're having like a party for her. So I'm going to get to go to Galveston, which will be fun. I'm trying to think of what else I'm doing over the break. I'm just going to see my family. Getting your driver's license. All right. Let's hope. We're hoping you get it, right? That's awesome. I failed my first driver's license test, but maybe I shouldn't say that on video. It's fine now. Everything's fine. Okay. Cool. Okay, so I just wanted to hear some of those things. Here's a quick reminder, spring break, okay? I hope that you guys do get to take a break on spring break and that you don't do school. Some of you guys, though, if we're honest, like have been taking a break when it's not spring break. Like you've kind of been not consistently working, and I don't know who that is at all. Like I don't know you, but you might know if you're like, oh yeah, I've been on spring break for the past couple of weeks. And so you may need to actually take this week to get caught up because no new deadlines are coming. So it's your 1 week to like get work done without new work piling up on you. So I really encourage you that if you're behind, to spend like a day on your spring break getting caught up, or to set a goal for yourself of what to do. But I will not be here. Okay. So on spring break, here are some links for you, and you can keep this PowerPoint slide with these links on it. So if you're on Unit 8, that YouTube link right here, Unit 8 tutorial playlist. I have a working playlist that I'm making that covers Unit 8 because Unit 8 is kind of hard, or it has some difficult concepts in it, and I break them down and explain how to do them in that unit. If you have not done your heat of solution activity, you won't be able to finish Unit 7. So if you skipped it, you have to come back to it, okay? And I made a tutorial video on it right there. If you are stuck on Unit 6 Quiz 2, I made a tutorial on that because a lot of people had the same questions there. If you need help with the math, Unit 6 and Unit 7 equations right here cover the summary of all the math and explanations of how to do each type of thing. If you like these PowerPoint slides that I make, all of the past PowerPoint slides are in that folder in the green sticky note right there. So all of the past lessons. Other resources here, chemistry reference guide, a resource website. I honestly haven't like polished this website, but I wanted to go ahead and share it because spring break is coming. So click on that resource website. Go ahead and click on that and open it up in a different tab. And you can see a list, like scroll through it. I'm going to share the tab as I open it. A list of chemistry resources here. This is a website that I'm still making, but it does have like a lot of different like links on it for you. So when you're on spring break, just know that that has a lot of stuff on it as well. And that's mainly it. Those are the main resources, a scientific calculator, if you need that. So come back to this slide, and these will also be on my landing page over spring break if you need these resources on spring break. So are there any questions on that? I haven't really been reading the chat. Any questions there? Okay, sounds great. Okay, so today, happy Hawaiian Day. I don't know if you guys got told, but we are doing Spirit Week this week. So I am wearing this Hawaiian shirt from the men's section at Walmart. So props to that. Happy Hawaiian Day. And tomorrow is, I think it's Mario Day. Can you all confirm that it's Mario Day? Does anybody else know that? Yes, yes. Tomorrow is Mario Day, but also any video game if you want. But it was originally Mario Day. But I need some ideas on outfits for that because I'm not incredibly, I haven't started the wheels turning on that one yet. So today we're going to learn about rates of reactions. By the end of this lesson, you're going to know 5 factors that affect the rate of a reaction. In this video here, hold on, let me pause it. This video here explains it, and we'll come back to this video if we have time for it. But if you watch this video, I love TED Ed. It's only 5 minutes, and it really simply explains how to speed up chemical reactions. But I'm going to ask you guys, because I think y'all know this already, some of this stuff. So if I ask you, how could you speed up a chemical reaction? Put in the chat, what are some things you could do to speed up a reaction? Catalyst, that's one of them. You could put a catalyst in and that would speed up the reaction. So I have a reaction that's going really slowly. How do I make that reaction go by quicker? Heat, Julia says heat. Okay, that's another one. Y'all have listed 2 so far. You can do anything you want to this reaction. Stirring it, I think that's a good one too. That could increase the rate of reaction. Anything else? Okay, shaking it. I might put like shaking and stirring in the same category. I love that. Adding something in, okay, we could make it more potent, make it more powerful. Tobias says increase the surface area. I love that response. Yes, that's another one. You could make, you could like flatten it out and increase the surface area of it. Okay, centrifuge. I love it. Y'all are so creative. I love these ideas. Centrifuge helps separate things. Like if you centrifuge, if you get your blood drawn and you take it, they actually centrifuge your blood to separate like the fats from the liquid. So then they only take like the liquid part. So centrifuge actually separates things, but I love that. The concentration. Okay, so this lesson is a fun lesson because it makes sense, okay? This lesson talks about what are some things we could do to speed up a reaction to happen, okay? And we're gonna come back to this video if we get to it. Hold on. So there's a couple of vocab words. The first one is catalysis. Catalysis is the action of a catalyst in a chemical reaction. So a catalyst is something that speeds up a reaction. So a catalysis is that process of that happening. And the second vocab word is a reaction rate. So a reaction rate is talking about how much the products form per second. So the rate of a reaction is like how much the products are forming per second. So it's how concentrated the products are per second. And if it's getting more and more concentrated over time, the reaction rate is increasing, if that makes sense. So we're going to talk about those factors. The terms fast and slow are relative. What seems fast to one person might seem slow to another. We all know that's true, right? Like, I'm a slow learner, in my opinion, compared to other people. So my version of fast for learning something is a lot slower than somebody else. Scientists like to deal in more specific terms, so we use a more specific definition. The reaction rate is how the concentration of products change over time. That's the more specific definition. So here's an example of different reaction rates. So look at the first reaction here, okay? That's actually a chemical reaction that's happening, and that looks like it's happening relatively quickly. Look how quick that's happening, okay? Now, here's another chemical reaction happening right here. You can notice this flower petal is changing colors over time and basically dehydrating. It's drying out over time, and this can take like weeks to months. I don't know if you've ever pressed a flower before, but it can take a long time. So both of these are reactions. They're happening, but they happen at different rates. So some reactions happen more quickly than others. So in order for a reaction to form, in order for a reaction to even happen, there are some things that has to happen. The reactants need to collide with one another or hit one another, right? And the collision needs to be forceful. It needs to be forceful enough. They need to hit hard enough for the reaction to happen with enough energy. And the second thing is that they have to be oriented correctly. So if the molecules aren't like oriented in the right direction, then even if they hit each other really hard, the reaction won't happen. So here's a picture showing that. So look at the first picture here. Here, they are colliding and they're colliding in the correct orientation, but they're not forceful enough. Okay, so there's no product that's being formed. And here, they are being forceful enough, but they're not at the right orientation. Look how these molecules are, one of them is flipped the other way, and so it won't happen. And then lastly, over here, they're at the correct angle, and they're forceful enough, and so in this situation, a product will form. So a lot of things have to go correctly for a reaction to even happen at an atomic level. Even if you have all the right things mixed in there, sometimes the reaction just doesn't happen because the atoms either aren't oriented correctly or there's not enough force there. Okay, so reaction rate, we talked about that definition. It's basically how often a collision happens. So there's 5 factors that affect it, and you guys have named these already. First of all, concentration. I know that Ari mentioned that, and I think Velvet mentioned that as well. She said add more product. So the concentration of a reaction rate helps it go by faster. And that makes sense, and I'll talk about why in a minute. Second is surface area. Surface area is like how spread out something is. If it's all condensed into like one cube versus like being flattened out, if it's all condensed, it has less surface area. So the more surface area something has, the easier it is to react. In the temperature, you guys said, Tobias said surface area, and I know some of y'all said temperature or heat. I forget who said that. Maybe, I think it was Julia who said heat. And the next one is the presence of a catalyst. I forget who said that, but somebody mentioned that as well. And then 5, the only one that y'all didn't mention is the inherent properties of the reactants, which that one kind of already makes sense. So let's talk about concentration. So y'all tell me, why would concentration make a reaction happen faster? Why do you think concentration, like if I increase the concentration, why would that help the reaction to happen? You can unmute yourself, or you can write it in the, you can write it down. Why do you think concentration would help? It takes a second to type this. More reactants means more products. So if you add in more concentration of them, you're going to get more products. I like that. Anything else? It increases space. Okay, so you're like packing them all in, right? Let me go back to this, to the other slide here, because this picture kind of helps. Okay, so if you add more and more atoms here, then more of them are going to collide, because the reaction happens when there is a collision and when there's force. So if you increase the concentration, you're going to have more collisions. Does that kind of make sense? There's more in there, so they're going to collide more often, so they're going to react more often. So it speeds up the rate of the reaction. A lower concentration is a lower rate of successful collisions, and so it would slow down the rate of reaction. So an analogy would be like more cars on the highway lead to more accidents on the highway, because the more cars you have, the more rate of collisions you probably will have. So that kind of makes sense, right? Okay. The second one is surface area. Okay. So for surface area, hold on, let me see here. I want to show you guys a picture to explain this. Let's see. So when you look at this picture here, these atoms are like all clumped together, right? But these atoms are all broken apart. So which one do you think will happen better? When they're all clumped together or when they're all spread apart? Which one do you think would make the reaction happen quicker? What is happening in this chat? Which one do you think? Which one do they happen together or spread apart? So the red atoms are trying to break them apart. What would be easier, if they're all clumped together or if they're spread apart? Y'all see that? Okay, I'm seeing some togethers and some apart. So if we want the reaction to happen quicker, right? See how here the red atoms can get in and kind of maneuver in more spaces? So when you break them apart and chunk them apart like that, it increases the ability for them to like get in there and break them apart. So the bottom picture has more surface area. More surface area is exposed, and the top one has less surface area. So when you crush something up, you're exposing surface area. So when you crush something or expose the surface area, you're going to increase the rate of a reaction that happens. Does that kind of make sense? Okay, y'all are changing your mind now. So spread apart, being spread apart exposes more parts of it and helps the reaction to happen quicker. Okay, and that's explaining it right there. The third factor is temperature. So y'all tell me, why would temperature impact the rate of reaction? Why would temperature increase the rate of reaction? Velvet says faster. So what about faster? What does temperature have to do with being fast? I get really nerdy about this. I think temperature is actually really cool. What is temperature? When you measure and you're 98.6 degrees, or you measure the temperature outside, what even is that? Like, what is temperature? Why are we so used to it? If you're looking at the atoms, what is temperature measuring? If you're looking at atoms, what does temperature measure? Zakarian, that's exactly right. Temperature measures how fast the molecules are moving. So when you're measuring temperature, literally all that you're doing is measuring how quickly something is moving. And the more quickly something moves, the hotter it gets. Okay, so temperature measures how fast atoms are moving. So if you increase the temperature, guess what? The collisions increase because they're moving faster. Okay, so as particles move faster, they collide more frequently, and more collisions means more products, right? It increases the reaction rate. And second, the kinetic energy increases, so it has a greater chance of breaking the bonds and colliding and forming complexes. Like, it's basically, those are really similar. Like, the kinetic energy is increasing, and so it's able to like have more energy to break the bonds, if that makes sense. Factor 4, adding a catalyst. So you may have learned about a catalyst in biology. A catalyst is something that alters the reaction rate. It increases the speed. And the catalyst is not consumed in the reaction. So it's there, it makes it go quicker, but it's not like a part of the reaction. It actually stays the same after the reaction. It's not consumed in it. It does combine with it for a short while, but at the end of the reaction, it is like removed again from the reaction. So adding a catalyst can speed up the reaction properties, and there are all sorts of different catalysts that you can use to speed up a reaction. And the last factor is the inherent properties. So sometimes, like for chemical substances, the inherent properties are determined by things like how many valence electrons they have, their bond energies, their molecular geometries, and those things make each molecule unique. And some things are more unstable and they want to break down. And some things are more stable and they're chill on their own. They're like, I don't need to react. I'm already stable. I don't need to actually interact with any other molecules. So molecules that are more unstable react more, and molecules that are stable don't really react at all. And so that can affect how quickly a reaction happens. So fluorine and chlorine react with a lot of substances because they're really unstable. And helium doesn't react hardly with anything because helium is a noble gas and it is really stable by itself. Table B1 and B2 in your chemistry reference guide shows you how active something is and how reactive it is if you want to look at that. Lastly is a little bit of math, but the good news is you don't have to actually do the math. You just have to like look at it and understand it. So we're not going to work any math problems today, thankfully, because we've done a lot of math recently, but we're going to learn like what is a reaction rate. So when you hear the word rate, what do you guys think of when you hear the word rate? Like anytime rate, like your rate is used sometimes like in math or rating a movie. Okay, I like that. If I'm talking about like the rate of doing something, change, Mark said change. Okay, how something changes over time. Speed. Okay, so rate measures how quickly something is changing over a period of time. Exactly, Brenna, I love that. So for measuring reaction rate, we measure molarity divided by time. Molarity divided by time. So molarity is concentration. So we're measuring how the concentration of the product changes over time. So for example, if your molarity is 5.2, if your molarity is 5.2 every second, your rate would be 5.2 moles per liter per second. So molarity is moles per liter, and we're measuring how much of that is being added on every second. So another example would be this here, like what's the reaction rate here, okay? Well, if you just look at the data table here, look at 50 seconds. At 50 seconds, we have 1 mole of product. P stands for product, right? So at 50 seconds, we have 1 mole of product. And so at that point, you would do the one mole per liter divided by 50. So you take the concentration here and you divide it by the time and you get 0.02. So you take the concentration and you divide it by the time it took to get there, and that tells you how quickly the reaction is happening. Okay, so real quick, I'm going to do a learning check. Y'all fill in the blank. Increasing the blank of reactants can increase the reaction rate because there are more particles. So which one of these has to do with adding in more particles? Okay, I'm getting it. We're hearing A here for concentration. Concentration adds in more particles. Great job. Next one. When reactants are not in the same state, the reaction rate can be increased by increasing the blank because the reaction can only take place when 2 reactions come into contact, and this increases the amount of area where particles come into contact. So which one increases the area where particles come into contact? I'm seeing D, surface area. Great job. So increasing the surface area increases particles coming into contact. Okay, this one, how does increasing the temperature increase the reaction rate? Does the kinetic energy increases and particles have a greater chance of breaking bonds? Or B, the particles of the reactants move faster and collide more frequently? C, the bonds are created without breaking the original ones and energy decreases. D, some molecules disappear into the atmosphere. E, molecules can form activated complexes. Which one do y'all think? Okay, I don't think it's going to be disappearing into the atmosphere for this one, although I think that one's really funny. The answer here is part B. The reactants move faster and collide more frequently. Great job. Almost last one. The presence of a blank may increase the reaction rate. Which one of this? Catalyst, exactly. The presence of a catalyst can increase the reaction rate. So those are our 5 factors that we learned about today. And we also learned that reaction rates are measured by tracking the change in concentration over time. So let me know if you guys have any questions on that. And then here is my resource page right here, just so you guys are aware. This is the code word for later, if you're watching this later. But here's my resource page over this unit, and then ask your questions here if you have any. Other than that, you guys are free to go. I will miss y'all over the break, and I'll see y'all the week after that for spring break, or come join my classroom if you need help with anything. Have a great day. Bye. Have a good week. Bye, Megan. Bye, Natalie. Bye, Joshua. Bye, Dalton. Y'all email me if you have questions. Come to my classroom. Bye, Shannon. Bye, Brenna.